friends and students. Welcome back once again. So today I'll be telling you about these two meters. That is, one is analog meter. This is analog meter, and this is digital meter. So what is how we can operate both the meters? Which one is good? That is, which one will test some parts? Will do some practical related to both the meters, right? We'll check some voltages. We'll check some components. We'll check some resistance with both the meters, and I will tell you which one is better in what category. Okay, so let's start our practical first. Okay, at the same time I will tell you about the breadboard also, how to arrange the breadboard, how to fix the component on the breadboard and everything. So this will be overall, this will be a video where you will learn about the multimeters, the comparison between these two meters, that is analog and digital multimeter, and also we'll have some idea about the circuits and the breadboard arrangement. Okay. Right. So let's start with the first part. That is, I will just tell you about this. What is the difference between these two meters? Okay. First, we will see what is the difference between these two meters. So this is analog multimeter. Analog multimeter. You can see the main difference between these two is the digital multimeter. You have a digital display. Okay, the display is digital. That is, we are using LCD over here. You don't have LCD here. There you have a dial scale. Dial scale. Okay, the white color part you can see here. That is, we call it a dial scale. And as soon as we move around, or like I will just show you how. Suppose I'm just putting it on a ohm, and you can see. Just a moment, please. Right. Okay. So you can see a meter movement. Okay. When I'm touching the probes here, like I'm just touching the probes, you can see the meter movement. So there is a needle and it works with the principle of electromagnetic principle. That means when the current is going inside, according to that, there is a small circuit. The moving coil will start move and the needle will start move from there. On the dial scale, you will find all the values written here, like ohms value is there, voltage value is there, AC DC voltage is there. Then you have dB levels also. dB is measured for your, it is measured for the sound level. Okay, please remember it is measured for the sound level. So analog multimeter and this is digital multimeter. So what is the common between these two multimeter? One is probe, that is positive negative probes will be there on both the side, right? Okay, the connections will be there on both the side. Second is this center part, that is we call it as a selector switch. Here also we have selector switch, here also we have selector switch. So whatever you want to do, whatever function you want to operate, you have to select that first, like voltage DC, voltage AC. Here also you have voltage DC, you have a separate voltage AC, then you have resistance and you have current, that is milliamps. Here also you have currents in milliamps, that is DC. Here also you have in DC. Okay, no AC. Okay, AC you cannot measure, only DC current milliamps is given in this multimeter. So that is the main difference between analog and digital multimeter. All right. Now what we'll do is we'll test one with this multimeter first. Okay, that analog. Okay, you can see one battery over here. That is, I will just I'm just having positive and negative probe from this meter. Okay, so I will just put positive and here and negative here, and let's see what it shows. It is not showing. Why it is showing full? Why? Because we by mistake we have not turned this properly. So I have to put it on 10 volt DC. Please remember this mistake. Oftenly we do that. We don't properly select the meter switch. That is selector switch. Okay. Now we'll see it. I have put it on DC now. I will put it on the probes on plus and minus. You can see it is showing approximately 3 volts, right? Here it is 4 and here it is 2. It is coming in between. You can see here. Right. Okay. If suppose I change the probe, like positive, by mistake, if I forget, so what will happen? Right. So I'm just changing the probe. Thus, you can see here, the needle is coming back on this side. You can see, right? The needle, it is coming on this side. So you can this side. So this is a disadvantage with this meter. That is, if you in this meter, if you see, you will not get the needle coming on this side. It will show negative. Okay, please remember it will show negative. Let's see that. Okay, let's check. So now we will switch off this thing. Voltage, I have put it on 20. Now I'm putting plus on this side and I'm just counting it, and I will see what is the voltage it's coming. It is showing 3.20. There it was showing 3 volts. So here it is accuracy is more. Okay, right. And I will reverse it now. You can see here I'm reversing it. So it is showing minus. Got my point? It is showing minus. So it was plus B. Now it is showing plus. Again, if I reverse the polarity, it is showing minus. Okay. So which one is better for a voltage measurement? So probably this is the best meter, or compared to this. Okay. Compared to analog, digital is better. Okay. So first point, I hope you understood the first. Now you can see, now what I will do is I will check the AC. You can see one transformer here. I've kept one transformer. This is a step down transformer. Primary is connected to the plug, that is 230 volts, and secondly we have 3 wires coming out. Okay, 1, 2, and 3. So what we will do is we'll measure the voltage. What is the voltage? First we'll measure the voltage with the analog multimeter. So I have kept it the analog multimeter to 50 range. This is AC volts. Okay, please remember this is AC volt. We are testing only the AC. So I'm putting one wire onto this, and the second wire I'm connecting to the another pin. So I've got approximately, it is showing 10 volts. Okay, 10 volt AC. Okay, now same thing we will do it with this multimeter, that is digital multimeter. Let's try it. Okay, let's try it. Okay, so this is a digital multimeter, and how much it is showing? Okay, we have to again the same mistake. I have to see, you have to change the this thing from here to there. That is, I've kept it to 200 volts AC. You have to change, but this is the mistake what we oftenly do, So that's why this is very important for you. So when you have to be very careful with the selector switch. It is showing 9.9 volts. So accuracy is more in this digital multimeter we are taking when we are testing AC volt also. So compared to this is better, okay, for testing the AC also. Got my point? Okay, you take it anything. So AC and DC we have tested, we have got the voltage. Okay, so we have got the correct voltage. Why? Because here in digital multimeter you have 0.0. Okay, here point will be, it will be there here, but sometimes no, it's a needle, it's a magnetic, it works on the magnetic principle. So sometimes you will very accurate, it will not be showing here, it will be after decimal, it will be showing accurate over here. So I hope you understood. So voltages AC and DC, which one is better? Digital multimeter is better. I hope you understood this particular point. All right, friends. Now I will just, let's discuss a little bit about the breadboard and the component on it. Okay. So you can see some components I have fixed it on the breadboard. So how I have fixed it, you can see from, we will starting from here. I have used 3 resistors. You can see here 1, 2, and 3. That is R1, R2, and R3. How it is connected? It is connected in series. How it is to be connected on the breadboard? You can just check it on this. Okay. So how the resistance is to be connected on the breadboard, that is very, very important, because usually what happens, when we ask you to do series and parallel connection on the breadboard, so you will get confused. So that's why I have kept it this 3 resistor R1, R2, and R3. And what is this part? What is this part? So this is called as preset. It has 3 points, 1, 2, and 3. Okay, what is what category of this thing it is? It is a variable resistor. Please remember. Okay, it has a 3 points, and because when you put a screwdriver in this, you vary it, the resistance will vary. Okay, so that you have to keep it in mind. Okay, I have used 3 capacitor here. 1, 2, 3. One electrolytic capacitor. Why? Because one of them, the first one, has polarity. Okay, the negative is on the other side. This side it is positive. And these 2 capacitors are non-polarized. Okay, these are also are connected in series only. But 2 PF capacitor, you can see here, 2 PF capacitor have connected here in the front side. Right, these are in parallel. Okay, these are in parallel. So parallel means what? How it will be connected? Parallel means both the ends of this thing will be connected to the other both the ends. Okay, it will be on the same line. What you have to understand, it has to be on the same line, this side also, that side also. Okay, in series, one end only will join the another, and another end will join this thing, like in a chain formation. Okay, so these are the arrangement. Now what you see here, this one, this is a switch. Okay, what type of switch? It's a micro switch. So while fixing a micro switch, please remember it has a two switches over here. So one is on this side and one is on that side. If suppose you want to use it, you fix it this way so that should be a gap in between. So you can utilize both the switches. Okay, so this is, you can call it this side as a switch 1 and this side as a switch 2. Okay, I will show you. I will show you with the multimeter how you use it. And I have made a small circuit with a diode series. You have one resistor and you have a LED. Again, I will show you this. There is a transistor over here. How I fix the transistor, that you have to see. You don't fix it like this. You have to fix it in a vertical position. Okay. That means the three terminals, emitter base, it should be separated. It should not come in a single line. That part you have to be very, very careful about. Okay. So I hope you understood this particular part. Now we will do the testing part. Now, please see. Now we'll come to the measurement part. Okay, I'm using this multimeter. Again, please remember, I told you this, I have to select whatever you are doing. When you are measuring the ohms, that is the ohms value, that is the resistance value, you put it on the ohms range. Okay, these are the ohms range. I will just put it on the ohms range here. Okay, got it? Okay, now I have put it on a ohms range, and now just see one R1. I'm just checking what is the value of the R1 here. It is showing approximately, it is showing around about 8 or 9. Okay, 9 kilo ohms it is showing. Okay, and the total value should be this corner to this corner. Like that you measure, isn't it? So R1 plus R2 plus R3. So likewise you have to measure. Okay, it is showing lesser. So more, sorry, so rather more. Okay, so likewise you have to, and this same resistor you can check also. Suppose this value, if you want to check this preset value, how you will check it with the multimeter? You please remember this end and that end, not the center one. This will give you the exact value. Approximately it is coming around it is coming around 2 or 4. Okay, okay, it is showing, but this value is approximately, it's written on that, it is 5 kilo ohms. Okay, so right. Okay, so write this. So I will now, what I will do is I will take this multimeter, that is my digital multimeter. I will take. Okay, and we'll measure the value with the digital multimeter. Same thing you have to do it here. You have to put it on 2K, or rather you can put it on 20, right? 10, 20K, and we'll check the value. Okay, so same R1, I will check the value. So R1, it is showing how much it is showing. Approximately, it is showing approximately 10. Okay, it is just varying, but please remember, I will just put it on this thing. So 9.78. Okay, so that there it was showing approximately 8. Here it is showing 9.7. The actual value, according to the color code, it is 10 kilo ohms. Brown, black, orange. So brown, black, orange is 10 kilo ohms. So it is showing approximately 10 kilo ohms. You must be thinking why it is showing 9.78, why it is not showing complete 10. Please remember there is a tolerance also, right? Tolerance is plus and minus. Okay. So likewise, you can just check the values of this. Let's check this value. Okay. So this is how much it is showing. Okay. It is 5K. No, I said no, 4.80, approximately 5K only. Okay. So likewise, you have to get, and here to the center, it will be showing what is the value, that is the total value, and left hand side, it will be another value. So if you add these two values, you will get the total value. Because if you put a screwdriver here, you can vary it. Please remember, it's a variable resistor. Okay. Now, please tell me, this capacitor I have connected right here in series. So can we measure this capacitor value in this? No, we cannot. Why? Because we need another multimeter, or rather another meter for measuring the capacitance value. That is called as the LCR meter, right? Where you can measure the inductance, capacitance, and resistance, three of these things. This doesn't have that facility, so we cannot measure. But I will tell you one trick. Okay, with these meters, you can just find it out whether my capacitor is short circuit. But which one capacitor? The non-polarized capacitor, you can check. Okay, so let's check with this meter first. Okay, I'm not changing anything over here. So let's see what we can do it. Okay, I have put it on both the end of this capacitor and it's not showing anything. Okay, please, the needle is not moving. Let's try with this. Okay, let's try with this also. That is the digital multimeter. Nothing is, no change at all. Okay, no change at all. What does it mean? That is, we are testing a whether my circuit, my capacitor is short circuited or not. If it would have been short circuited, that is, if it would have been short, then it would have certainly it would have shown some resistance. This is short. Please remember, 000 is a short. I'm just touching it. You can see this is short. Now it is open. If I'm not touching anything, it is open. Same case here also. So this thing is open. But please remember, the short circuit is not there. That's the one trick. Okay. Now, very important part is, if suppose electrolytic capacitor, how you're going to check it? All right. Now what I will do, you can see I've connected one capacitor. This is a 1000 microfarad 25 volt capacitor, and I will check with this multimeter. That is your analog multimeter. I've taken the analog multimeter probes. So you just watch it. What would happen? What you are going to see it? Okay. So can you see now the needle is coming back slowly? Okay, right? Okay, it is coming back slowly. Then I will reverse it again this side, and you see what happens here. Same thing. Okay, it is on the top, and it slowly it will come back again. Okay, it will come back again. So what is it is showing? It is showing the property of this capacitor, that is, it is getting charged and discharged. Okay, now let's do one thing. We will check this probe, that is the digital multimeter probe, and we will check what it is showing on the multimeter. Same ohms range I am doing it. Same here also. It was increasing, and then again it is decreasing. Sometimes it is increasing also. Okay, but only the difference is here the needle was coming back. Here you are getting the numbers. Okay, your numbers are changing. Okay, so I'm just reversing it again, and you just see what happens here. Okay, right. So it is changing, increasing, then slowly it is decreasing. But I will suggest you, what I find is, in this case, that is the testing of the capacitor. What capacitor? Polarized capacitor. I find this is better, right? The analog multimeter is better. Okay. Why? Because you can just clearly find it out. The needle was coming back. So in one case, at least, we found that this is better than this. The numbers may be increasing, sometimes decreasing. You get confused. But here, once it increases slowly, it will get discharged. That will show that the capacitor is good enough. Okay. That is the one of the testing you have to understand. Okay. Right. So we'll remove this, and I will tell you how to test this thing, like that is switch. So switch, I will just tell you, it's a bell type of switch. That is, when you press it, then only it will switch on. You can see I'm pressing it, right? It came to 0. With switches and all, you can check with the buzzer also. We have a buzzer mode here. So I will just put it on the buzzer mode, and you can check on the buzzer mode also. It will give you a sound, but probably you might not be hearing the sound, but it is giving the sound. Okay, right. So this is simple testing. So this side also the same, it will be there, because I told you when 4-pin, it is both the side, it will be there. Okay, right. So you can use both the switches. If suppose you put it on this side, sometimes it may get short because you don't know what to arrange on the breadboard here. Sometimes you do mistake here. So my idea is to tell you, to guide you, that this is the best place where you can fix it. These two lines are internally connected to each other. Please remember, right? These two lines and these two lines are internally connected. That's why we have separated it. Okay. So this, you got it. I hope you understood this particular point. Let's try with this also. That is this thing also. You can see the same thing will happen. Okay. I'm just connecting it and pressing it. Okay. So slowly it is going towards 0, right? That is, I'm connecting it, and it's going towards the 0. Same thing that side also. So comparatively, both the things are same here in the case of switch. Okay. Now what we will do is, with the analog multimeter. Okay, with the analog multimeter, we'll test this transistor. Okay, there is a transistor over here. You can see the transistor here, emitter base collector. I've put it separately. The center is the base, and I'm putting a center, the base black color wire, and we are testing on the analog multimeter. So this side I've seen, okay, some resistance has come. Other side, some resistance have come. Okay, I will reverse it. Now I put a black on the center, and I will just see it is not coming. It is not coming. One more thing I will tell you. One more thing. Please remember, if you have an analog meter, emitter and collector also you can test it. Okay, emitter and collector also you can test it. Okay, right. Okay, so there is a little movement on this needle when you put it on this. Okay, it's not even the hand resistor. I'm not touching anything. So little resistance was there. Okay, now what we will do, the same transistor will test with your digital multimeter. Where you have to put it? Where you have to keep this thing? I will put it on a diode board here. There is a symbol given in the digital multimeter. You have to put it on that. So black probe in the center, right? And red on here on other side. Okay, nothing is coming. Okay, this is nothing is coming. So what I will do, I will reverse it and I will just check it. Okay. No, why it is not coming? 1 second, please. I will just check. Okay. 1 second, please. So am I mistaken? Okay, no, right. Okay. So 1 second, I will check again. Okay, so when red is on the base, you have got resistance 8.14. On emitter, other side, you got approximately 8.14, not 8.14, 8.02. Okay, when I'm putting center, that is black, it is not giving me anything. So both the cases, it was same. But let's see what is emitter and collectors. So no change here. Okay, please remember, no change here. Here also, there is a no change. Okay, right. So there we found little movement in that mechanism. That is, you please remember, in a transistor, you have two junctions, right? PNP or NPN, two junctions are there. So if there is a little leakage in between the junction, it will show on this multimeter properly. That it will not show on this properly. Of course, you can test the transistor. I'm not saying that you cannot test the transistor on this, but the leakage part will be shown properly on this multimeter. That is, analog is better. So I gave for this transit testing, I give this one now, the better chance. Okay, now test the diode. Okay, this anode and cathode. I will test it. One side it is coming, another side it is not coming. Okay, when it's not coming. Let's try with this. Let us, okay, with the resistance only, we'll try it. One side it is coming, other side it is not coming. Okay, so almost same. So diode almost same. So my suggestion would be, for testing the semiconductor diodes and the semiconductor material transistor, that is these both of them are made up of semiconductor material, that is silicon. So if you want to check this transistor and diode, please use this. That is my suggestion. Why? Because my experience tells if there is a leakage and all, it will be shown on this particular meter, that is analog multimeter problem. Okay, so that you understood. I hope you understood this particular point. So we are just categorizing, we are just checking which one is better and which is not better. Please remember, these type of videos you will not find, because this comes only with the experience. If you find it good, please share with your friends. Please give us a thumbs up and please write to us. Okay, what exactly is your need and how we can help you out, and what type of study material or what type of practicals and you want. Please remember, I only believe hands-on practical. When we do practical, then only we'll understand. Industry wants practical only. Please remember, that is why I will be doing all hands-on work and I will be teaching about that only. Okay, right, okay. So finally, last thing, I would just like to tell you one last. I've connected the transformer secondary side to the circuit. I told you this is a small circuit. Okay. So one end is going to the anode of the diode, another end of the diode, that is cathode, through resistor, that is 220 ohm resistor. I've given it to the LED, and LED another end is going to ground. This is a small circuit. And of course, I have used one capacitor also, the same capacitor, that is positive end, it is coming here, and negative, it is going to the negative end of the LED. So transformer one end connected to negative and another end to the diode. Now we will check the voltage. First, what we will do is, please remember, when you want to check the DC voltage, again, I am telling you, you have to be very careful. That is, you have to put it on a proper value, or the button should be, or the selector switch should be on a proper place. So I put it on 10 volts. Please remember, polarity is very important. When you're working on DC, polarity is very important. So black color is negative. I'm putting negative on the negative line. This is a negative rail. Okay, please. On a breadboard, this side and this side, it is either you can use it as a positive rail or you can use it as a negative rail. Okay, so I have used this one and I'm just checking the DC voltage now. Okay, DC is, it's showing approximately 5 volts over here because it is in between 4 and 5. So you can see here 4 and 5. So you can see just once again I will show you. So you can see it is showing approximately 5 volt. Let's check with this multimeter. That is digital multimeter again. So negative, again, negative, positive, DC 20 volts. So you have to be very, very careful about that. Selecting this thing, and you should get a DC over here. It is showing 5.06. So you can see 0.5.06. So which one is accurate? This is accurate. Okay, because you have after decimal, you have got two values. Here it was showing just approximately, we were taking it as the 5 volt only. Here it is 5.2 or 5.0 something. It was showing 5.2019. Likewise, it is showing. Please remember, this is the advantage. So voltage and this thing current also you can measure with both, because current AC current, not AC current, it only DC current, both the meters you can measure. So some other video next time I will tell you how to measure the current. This is the DC voltage I've given you. So advantage comes to whom? Here also the advantage came to this. Okay, right? The advantage came to the digital multimeters. So that's why finally I will tell you, for AC and DC voltage and current, this meter, that is digital multi, is better. But when you testing a cold check of the component, that is transistor and diode, which is made up of silicon, this is better, right? Switches, both the side, it is okay. Okay, switches, that is, we call it as a continuity test, it is okay. Accuracy of resistor, again, this has won, that is a digital multimeter is better, and this is little near what value we got it. Okay, but continuity, this both the thing were okay. So overall, this meter, that is digital multimeter, is every time better than the analog multimeter. But some cases, your analog multimeter, that is testing of cold check of the diodes and transistor, that's leakage and all, this is better option. I hope you enjoyed this video, and if anything is there, please subscribe and like to my videos. Thank you.